Welcome, this is Edexcel, January 2012, question 5. It's quite a nice one, this, even though it looks, you look at that and go, wow, look at that, it's got all squiggly things all over it, and it looks insane, it looks crazy. Who would ever even try to attempt that crazy thing? What idiot would come up with that x equals 4 sine t plus pi on 6 and y equals 3 cos 2t? What crazy thing made this up? Well, it's actually a lot easier. This question really, it's question 5, so your head's already screwed in the exam by this point. Well, mine is anyway. So you get to this question, you go, oh, okay, what the hell does that look like? Oh, I'll just skip it because it looks insane. But actually, it's parametric equations, and very good. The graph looks like that, but we don't need to do anything with that graph. That's just purely, we could do this question without looking at this graph, really. The part B sort of asks about the turning points, and obviously you've got a couple there. But you could do this without looking at the graph at all. There's many possibilities that you could say, okay, well, I don't need this graph. I can just purely do it from these two. Okay, so that's one of the key things. Now, you know it's parametric equations because we've got x equals one thing and x equals another, because we've got this third parameter that we call t. Okay, so the first one says, first question says, find dy dx. Okay, well, dy dx is, we use a chain rule for this, so dy over d something times the same d something over d dx. Okay, now the only other something we've got there is t. Okay, so dy dt and dt dx. Now, what I'm going to do is I'm going to break this up, working out what dy dt is and what dt dx is. So if we work out what dy dt is, so dy dt is the y equation, and we differentiate it with respect to t. So we can do that straight off the bat. We don't need to rearrange anything. So 3 cos 2t. When we differentiate cos, we get sine. We get negative sine, sorry. So, and then when we get 3 cos 2t, so we get 3 times negative 2. So that'd be negative 6 cos, sine 2t. Oh, sine 2t. Okay? And then we work out what dt dx is. Now, dt dx, think about what it's saying. It says differentiate the t equation with any x's that might be in there. But we can't do that because we don't have an equation for t. We've got an equation for x that involves t, so we could do, the only thing we could do is dx dt, but that's not being required. But you have to remember, 1 over dy dx is dx dy, so therefore 1 over dt dx is dx dt. So therefore, we work out what dx dt is first. So when we differentiate sine, we get cos, so it's just 4 cos t plus pi on 6. Now don't get confused because it's got t plus pi on 6, and okay, how do you do the derivative of that? Well, it's just 1 because pi on 6 is just a number. It's not, if it was t squared then it'd be 2t, fair enough, but because pi on 6 is just a number, t differentiates just to get 1, so it just becomes 4 cos of the same angle. But you have to remember, we don't want dx dt, we want dt dx. So dt dx is 1 over dx dt. Okay? So therefore 1 over dx dt is 1 over 4 cos t plus pi by 6. So it's 4 cos t plus pi on 6. Okay? So therefore we can write this in now, that dt dx is 1 over 4 cos t plus pi on 6. Okay? So what we do is put what we now know into the chain rule. So really starting to get into this old math stuff we're doing here. Okay, so we make that equal. So we say, okay, well dy dx is equal to dy dt. So dy dt is negative sine 2t. What I like to do to make myself that little bit more smart, look that little bit more smart, put it in square brackets so you don't mix it up, because you know that probably would cause a few nuclear bombs to go off, but you know, nothing too bad. 4 cos t plus pi on 6. So we can simplify this down. So then we just get, if we simplify this down, we just get negative 6 2t, negative 6 sine 2t, sorry, over 4 cos t plus pi on 6. Okay, nothing more you can do with that. You just say that is what dy dx equals. Okay, so that's part A done. So this is question 5. Just put that up there. That's part A. So if I cut this off, we're not going to start cutting the board up. That'd be, you know, I probably wouldn't, you know, it wouldn't go down too well with everyone else. So anyway, question 5, part B said find all the find the coordinates. Gives you a clue. It's going to be more than one on the point on the curve C where dy dx equals 0. So dy dx equals 0. So if dy dx equals 0, then this equation that we've worked out what dy dx is, that equals 0. So negative sine 2t over 4 cos t plus pi on 6 equals 0. Okay, so if we times both sides by 4 cos t pi on 6, so we get negative 6 sine 2t is equal to 0. Divide both sides by 6, so sine 2t is equal to 0. Divide both sides by negative 6, sorry. That's equal to 0. Inverse sine, so 2t is equal to the inverse sine of 0. Now, I mean, obviously I do know this straight off the bat, but I don't want to muck it up. So the sine inverse is 0 on your calculator. Make sure it's in radians, by the way. You always tell us in radians because if it mentions pi as part of the angle, you know, you need to know that. So therefore 2t is equal to 0. So what I do then is draw your cast diagram. So in terms of pi, that's 0 and 2 pi, pi on 2, and then pi, and then 3 pi on 2. Okay, so you've got to remember where sine is positive, so so cos, all, sine, tan. We want where all and sine is positive. So make sure I'm doing this right. Sorry, obviously I know I'm doing it right. So if you were to work that out, you would get pi, 2 pi, and 3 pi, and obviously 0 as well. So that's because you would have to imagine the range that we're given is between 0 and 2 pi, but that's for t. We're considering 2t here. Now you could say, okay, we'll just divide the range by 2, but it's not really what it is. You're meant to double the range and then you halve it again. That's what I do. So they're your answers for 2t, but we need to halve them. Half of 0 is 0, and then we've got pi on 2, 2 pi over 2 is pi, and then 3 pi on 2. But you've got to remember these are values for t. Okay, so I did that by just using the cast diagram, or just remember it in your head, whichever way you prefer to. I avoided this because I didn't want to make a mess of. I need some room down here. So we got the values for t here, but that's not what it's asking. Okay, this t doesn't tell us anything. The only thing it tells us is it enables us to work out the value for x and the value for y. Okay, so what we're going to do now is put these t values in for x and y. So you can have a go at doing that, but you should get the coordinates 2, 3, 2 root 3, and minus 3, and minus 2, 3, and minus 2 root 3, minus 3. Okay, so they're your 4 turning points. Now, if you were to use the diagram above, you could, I mean, it wouldn't necessarily ask you, but you know we're going to have 4 turning points because we've got a turning point there, turning point there, turning point there, and turning point there. And if you're really being anal about it, you could match them all up and draw it on, but that'd be just a waste of time, really. You can do that at the end of the exam if you have some spare time. Anyway, so that's the answer to question 5. It's quite a nice one. It looks a hell of a lot more complicated than it actually is, I think you'll agree. I mean, this bit I probably could have explained a little bit better, but as I said, I put the cast diagram on there for you to look at, so you can have a go if you want to, but you know, nothing too, I wouldn't rush to it too much. Okay, so thanks for watching. Hopefully it's been of some help, and we'll see you in the next video.